Okay, good morning everyone. So here we are. This is your worksheet 9. Okay, I hope you have updated the content page already. Alright, okay, so this one is under worksheet 9 qualitative analysis notes. We'll be doing this one. Okay, so page 5. Okay, so this is page 5. So today we'll be doing the anion test, okay, as well as the test for gases. So earlier on, for the cation test, we have done quite a few. You should have done this video during your HBL, okay, or during your March holiday. Okay, so let's take a look at the anion test for today. So cation test, remember the way we discussed as a summary how to memorize them. Okay, so let's take a look today at anion test. So anion test is not like cation test. Okay, so cation test is quite common. Okay, so as a revision, cation test is usually you use two ways to test. Right, remember two ways to test. Okay, first way is by sodium hydroxide. Okay, sodium hydroxide. Second way is by aqueous ammonia. Right, okay, and then most of the time you get colored precipitates, okay, except for when it's ammonium ions. Okay, this one is your ammonium ion. Okay, that one you get a colorless and pungent gas, and then that one is the only exception. You are doing ammonium salt and alkaline reaction. Okay, so this one down here we are actually doing ammonium salt plus alkaline reaction. Okay, that one gives you ammonia gas plus salt plus water. Okay, I like to call it AAASW. Alright, okay, but the rest mostly is precipitation reaction. Okay, and the rest, if you see, most of the time you're actually getting hydroxide as the product. Okay, copper 2 hydroxide for the blue one. The iron 3 one, the reddish brown one, is iron 3 hydroxide. The iron 2 green color one is iron 2 hydroxide. Okay, the white ones you have calcium hydroxide, lead 2 hydroxide, and zinc hydroxide. Alright, okay, so the precipitates are actually all hydroxide. Okay, so the PPT that you get is all hydroxide. As a recap, okay, they are all insoluble hydroxides. Okay, so if you forget everything in the previous segment, at least remember these two things. Okay, because sometimes they ask you about the colored precipitates. They are all hydroxide. At least remember these two things. Okay, so this part down here, please copy it down. Okay, it's quite important. Alright, okay, I put a heart shape. Okay, so officially start with the new things is anion test. So each anion test has a different test. Okay, for the carbonate, there is no need to make a solution. Okay, so remember earlier on we say that qualitative analysis, which is QA. Okay, qualitative analysis, which is QA. What you do is that you always perform on solutions. Except for carbonate, you don't need to perform on solutions. Okay, not on solid. You cannot do on solid QA. Right, okay, for other anion you have to make a solution, usually by distilled water. Okay, so for observation, there's namely two ways okay, that you will write the observations for anion test. Usually if got gas, you will write color, smell, and effervescence. Okay, usually effervescence is when you get a insoluble gas. Yeah, then you have a effervescence. Okay, sometimes you have the color of your precipitate. Sometimes you have a precipitation reaction during your test for anion. Okay, there's a couple of them, like chloride and then sulfate. Alright, so this one is usually your chloride test or your sulfate test. Okay, sulfate is SO42 minus. Okay, I hope you at least know this. Don't forget everything. Okay, so there's 4 anion tests to do okay, in this segment. Then after that, we're going to practice. Okay, so very quickly, let's get started. Okay, so okay, for your carbonate test, okay, okay, maybe before get started, I show you the video first, okay, so that you actually see how we do it. Okay, for those who have done the practical, basically, you should have done it already. Should be clearer how actually I do this thing. Okay, let me show you this one. Wait, let me see, is it this one? Test for anion. Okay, right, let's have a look. Okay, so the first one is the test for nitrate. You will be adding aqueous sodium hydroxide followed by aluminium foil, and you are warming it. Okay, I'll tell you what's the function of the aluminium foil in a short while. Okay, so the guy is adding a sodium hydroxide, and then this is the aluminium foil. Okay, then this is effervescence, not precipitate. A lot of bubbles coming out. Okay, then what he need to do is he need to warm it. Yeah. Okay, so your red litmus paper will turn blue, so you can see that it's ammonia gas, okay, an alkaline gas coming out. Okay, in your syllabus not a lot of alkaline gas, just ammonia only, actually, just one. Okay, then you have your test for carbonate, which is add acid, and then you will have carbon dioxide coming out, and then you bubble it into lime water, and then later on we'll look at what is the white precipitate. That for the past 2 years or so, you have been saying white precipitate forms in lime water. Well, what exactly is this white precipitate? We'll be looking at that. So standard thing okay, you add the dilute acid into the carbonate, then you bubble gas into lime water alright, okay. Alright, so for the chloride test, you actually add dilute acid followed by silver nitrate. So for this one and the sulfate test, you will see a precipitate. Okay, and we'll discuss what is this precipitate, okay, later on. It is a silver chloride. Okay, this one is not in your syllabus. Okay, you test it by basically lactone nitrate. Okay, for your iodide. You'll see a yellow precipitate, but this one is not in your syllabus. Okay, so you just watch for your information only. Okay, sulfate, this one is in your syllabus. You add dilute nitric acid followed by barium nitrate. Okay, you will get a white precipitate for this one. So back to the video, back to the notes. Alright, so for your test for carbonate, okay, basically you add dilute hydrochloric acid or nitric acid, and then you pass the gas into lime water. Okay, first thing first, okay, you got to know what's your lime water. Lime water is basically aqueous calcium hydroxide. Okay. Is a alkaline basically. Alright, the formula is this way, calcium hydroxide. Okay, alright, okay, so for carbon dioxide gas, okay, you'll see a couple of observation. When you add the carbonate into the lime into acid okay, so basically maybe I write the equation over here. Okay, so whatever carbonate it is, then you add your acid, let's say your nitric acid. Okay, X is whatever cation it is. I'm more interested in anion in this case, anion test. Okay, then you get your carbon dioxide gas. Okay, acid plus carbonate. Okay, then you get carbon dioxide, salt, and water. Okay, so for that, okay, you have effervescence because carbon dioxide, right, not very soluble in water, colorless and odorless gas. Okay, and then you'll get a white precipitate formed in lime water. Okay, so what actually is this white precipitate? You have been saying it for the past 2 years or maybe even 3 years. Okay, so this one is actually formed between, because lime water earlier I told you is calcium hydroxide. Okay, so basically calcium hydroxide, okay, will react with your carbon dioxide gas. This is aqueous. Okay, so carbon dioxide, if you recall, during your test we talked about oxides, right? Okay, it's actually a acidic oxide. Okay, how I see, it's a non-metal dioxide. Okay, that's why it's a acidic gas. Right? Okay, so yeah, so basically this non-metal dioxide reacts with your calcium hydroxide, then gives you calcium carbonate. Okay, so it's like an acid and alkaline reaction. Okay, this is an alkaline. Okay, then you get your salt. Your salt is calcium carbonate. Okay, formula why is it so? Because calcium is from group 2. Okay, carbonate is CO3 2 minus. Okay, there's a periodic table at the end of this. Yeah, correct. Okay, so you can see your periodic table. Yeah, okay, so calcium is over here. So that's why 2 plus. Okay. Yeah. Okay, so calcium carbonate, sorry, state symbol is wrong. okay, is an insoluble salt. Alright, that's why it's a white PPT. Okay, then plus your water lah. Okay, so what is that white precipitate? Okay, the white precipitate is actually this thing, calcium carbonate. Alright, so sometimes they ask you what is the white precipitate, you must know lah. Okay, so this one important to know. Alright, okay, so next thing, okay, you have your chloride. Okay, so previous one, take note, white precipitate is calcium carbonate. So now you have your chloride. Okay, chloride, you add dilute nitric acid followed by aqueous silver chloride. Silver nitrate, sorry. Silver nitrate. Okay, so these two you will see a PPT. Okay, so in this case, white precipitate is formed. Okay, and then the white precipitate is not soluble in insoluble in nitric acid. Okay, so the observation is a white PPT form. Okay, and then what is this white PPT, you have to know lah. Okay, so this white PPT is actually your AgCl. Okay, silver chloride. The name is silver chloride. Okay, alright. Okay, so I write an example of an equation. Okay, for the formation of this white precipitate. Okay, for example, you are testing a solution with chloride. Okay, maybe you can think of one solution with chloride. Okay, maybe let's say potassium chloride lah, let's say. Okay, soluble one. Okay, because sparse salts, right? Okay, then plus your silver nitrate, AgNO3 aqueous. Silver is always +1. It's not in group 1, but it's always +1. Yeah, do I have a periodic table down here? Okay, no. Okay, never mind. Use the periodic table at the end. Okay, so silver is here. Okay, it's always 1 plus. Okay, zinc is always 2 plus. Okay, although they are not in group 1 and group 2 respectively. Okay, so this will give you silver chloride. Okay, you are doing a precipitation reaction. Okay, so this one down here, I'm doing a precipitation. So basically is two solutions together as the reactant, then give one PPT precipitate. Alright, okay, so this is your white precipitate, silver chloride. Okay, then plus potassium nitrate. Okay, as the byproduct. Byproduct means not the other product. Okay, so this one, the white precipitate is actually this one, silver chloride. Okay, so take note, white precipitate is silver chloride, because sometimes they will ask you what is the white precipitate. Alright, then this one you got to know lah. Then as well as the ionic equation for the formation of silver chloride. Okay, there's a shortcut lah. Okay, so basically ionic equation, once you know it's a precipitate reaction, there's a shortcut lah. Okay, shortcut, basically you just add the cation, okay, to the anion. Add the cation to the anion. Okay, and then you have your silver chloride. Okay, add the cation to the anion, then give the precipitate. Okay, that's a shortcut for your ionic equation of precipitation, just like in cation test. Okay, then next thing we have your sulfate test. Okay, so sulfate test is nitric acid followed by aqueous barium nitrate. Okay, so this case also you actually form a white precipitate, and the white precipitate is actually your barium sulfate. Okay, So once again, you have the very important ionic equation as well as the chemical equation. Okay, so you can use the shortcut lah. Okay, but later I show you the long way. Okay, at the bottom. Okay. Okay, so now okay, let's think of a solution with sulfate. Okay, maybe let's have, let me see iron sulfate lah, iron 2 sulfate. Quite common one, this one. Iron 2 sulfate okay. Sulfate is SO4 2 minus then you plus your barium nitrate barium is from group 2, nitrate is NO3 minus so okay, so yeah, iron 2 sulfate plus your barium nitrate okay, barium is in group 2 in case you are wondering how come it's 2 plus. Okay, barium is down here. Okay, also 2 plus. Okay, okay, then you have so basically just exchange the partners for the ions so just swap around when you do precipitation. Okay, so now you have barium sulfate, that's the white precipitate, plus iron 2 nitrate. Sorry, not enough space. Actually, by right, I should squeeze it inside the box. Okay, right until too big already, my handwriting. Okay, so yeah, alright. Okay, so I show you the white precipitate is actually barium sulfate. This one important to know. Okay, this one okay, as well as the ionic equation. Okay, so I show you the long way for the ionic equation now. Okay, so what I have to do for ionic equation, if you're not doing the shortcut is you break the aqueous and aqueous one, then you cancel common ions. Okay, so I break all the AQ1 into the ions. Okay, solid liquid gas stay lah. Okay, so I will do this Fe2 plus SO4 2 minus. So which means you have to be quite good with the formula of ions as well. Okay, Ba2 plus, then this one is 2 NO3 minus, you have 2 nitrate. Then the solid one just stay, just copy down the entire thing, no need to do anything. Then you have Fe2 plus and then 2 nitrates. Okay, so what I have down here is the same ones I will cancel out. Okay, cancel out common ions on the left and right. Okay, then the Fe2 plus cancel. Then our final answer will look this way. You have SO4 2 minus plus Va2 plus aqueous, then gives you VaSO4 solid. Okay, yeah, so that's how you get an ionic equation. Okay, alright, okay, now moving on. Okay, you have nitrate. Nitrate is nitrate test NO3 minus. Okay, so this one you don't have precipitate, you get a gas instead. Okay, so this one you have add sodium hydroxide followed by a piece of aluminium foil or aluminium strip. Okay, looks more like strip in the video. Sometimes you add the aluminium powder. Okay, then you need to warm the mixture. Okay, warming a mixture, the reason is because you want to decrease solubility of ammonia. Of your ammonia gas. Okay, ammonia gas very soluble in water one. Then you test the gas with moist red litmus paper. Okay, this one very easily confused with cation test. Okay, very easily confused with a cation test. Okay, easily confused. No equation, but very easily confused with cation test. Okay, because that one cation test also got sodium hydroxide. Okay, you look back cation test, you also add aqueous sodium hydroxide. Okay, then especially this one, ammonium one, you also get ammonia gas coming up. Okay, so very easily confused with this one. Okay, so what you have to do is be careful. Look out for this aluminium foil. then it's a test for nitrate. All right. Okay, so this case you have effervescence, pungent and colorless gas, and then you have your moist red litmus paper will turn blue. Okay, actually effervescence not so important, in this case you can cancel out, because the ammonia gas is very soluble. Okay, yeah. Okay, so what is the purpose of the aluminum foil? It's basically to turn the nitrate, right? You add aluminum foil is to turn the nitrate to ammonium. Basically, it's a redox reaction that we'll learn in the next chapter lah. Okay, I write after this. Okay, then the ammonium will react with your sodium hydroxide, then give you ammonia gas. Okay, that's how the things are. You don't really have to know this redox behind it lah. I'm just telling you. Okay, you don't really have to know. Alright. Okay, then that's it for a nitrate test. No equations to learn for this one. Yeah, unlike the chloride and sulfate one. Okay, alright. Okay, one thing I forget to tell you lah, but they seldom ask you on this is how come you need to add nitric acid. Okay, you notice there's nitric acid that I add, but it's somehow in the equation there's no nitric acid. It is kind of weird, right? Okay, I add nitric acid, but in the equation, there's no nitric acid. So you add actually for what? Okay, the reason you add nitric acid is this okay. The reason for adding nitric acid is this. Is because you want to get rid of any carbonate, okay, to remove carbonate ions. Yeah, because if there's carbonate you also get a white precipitate. Okay, so you see let's say for some reason very unlucky, or test tube dirty, inside got carbonate. Okay, then let's say you add silver nitrate inside okay, then you will get silver carbonate, which is also a white PPT. Okay, and then the other one is the X nitrate. I keep on writing wrong state symbols today. Okay, right. Okay, so this one is also a white PPT. Okay, then you don't know the white PPT is because of this or because of your silver chloride. Yeah, same goes for the barium one. Okay, you also get the white PPT. Then you don't know it's because of what. So if by adding a nitric acid it removes this carbonate. Yeah, so the carbonate will react with the acid Say you have the silver carbonate, it removes it by reacting with it Okay, so this one what you have to do is you just copy down the reason okay, to remove carbonate. The equation I think you don't need to write down, right? No need to write down the equation. Okay, so this one gives you carbon dioxide, I think silver nitrate plus water. My equation is not balanced okay, just showing you how it removes the carbonate only. Alright, okay. Okay, so as a sum up okay, the white precipitate you form down here, the white precipitate is barium sulfate that's a white precipitate. This one is silver chloride. Okay, and then you have the other two okay. What else I'm gonna tell you. Yeah, then know the equations and the ionic equations also for these two. Okay, so next last thing is the test for gases. Okay, which I think in N level you already learned the first three okay, plus ammonia gas. Okay, so these two is new chlorine gas and sulfur dioxide. Okay, alright. Okay, so let's watch a video before we start this part. Okay, I should be able to go faster because you already learned most of this before, right? Okay, is this one a test for gases? Okay, this is a test for gases. Nothing new. Most of it you do before, except for chlorine and sulfur. So the test for carbon dioxide pass by so fast. Okay, so carbon dioxide, you bubble into lime water lah. So I hope now you know what's the white precipitate area. Okay, is actually your calcium carbonate. Alright, okay, and then test for hydrogen. Next one. Your burning spin, it extinguishes with a pop sound. You use a glowing spin in this case. The black color powder, I think, is the catalyst for this reaction. Catalyst, I'll explain why. It's a substance to speed up the reaction. Okay, and then test for chlorine. Okay, this one usually you have bleach plus sulfuric acid to get this reaction. Okay, you need to warm the chlorine also. Warm the solution because chlorine very soluble. Okay, then your moist blue litmus paper will turn red, then get bleach. Okay, because chlorine gas is actually acidic. This is something new. Sulfur dioxide, you use a purple color solution. You soak the filter paper in a purple color solution called potassium manganate. Alright, okay, it's a oxidizing agent. We'll explain about it in the next chapter. So basically, you use it to test for the sulfur dioxide. If it turns colorless, the filter paper will turn white. That means sulfur dioxide is there. It's a rotten egg smell, sulfur dioxide. Will turn white. Okay, so going back to the notes. Alright, okay, so hydrogen gas, you should be able to see colorless and odorless gas. Okay, and then you also have effervescence because not very soluble. Okay, so basically you place a burning spleen or what we call a lighted spleen, either way also can. Okay, at the mouth of the test tube. Okay, then it extinguishes with a pop sound. Okay, so usually reactions that get hydrogen gas, you should be quite familiar. Acid metal, metal and cold water, metal as well as steam. Okay, metal and steam actually gives you metal oxide plus hydrogen, but metal with cold water then is different. They will give you metal hydroxide. different hydroxide plus hydrogen. Okay, then you have oxygen gas. Okay, so oxygen gas is also is a colorless and no smell gas lah. Okay, so also you get effervescence. Okay, then you insert glowing spleen. Okay, into the test tube. So glowing spleen will then gets relighted. Okay, so normally reactions that produce oxygen gas, you have, like, for example, hydrogen peroxide decomposed to water and oxygen gas. Okay, this one is the one you need to add. The black color powder is manganese 4 oxide. Okay, it's basically a catalyst. I will explain a bit more about this, okay, in speed of reaction. Okay, then next thing you have carbon dioxide. Okay, carbon dioxide is actually a colorless, odorless gas. Okay, and then you bubble the gas into lime water. Okay, so hopefully by now you know what's the white precipitate. Okay, the white precipitate is actually calcium carbonate. Okay, and I've shown you how it's formed. Basically, between calcium hydroxide, which is your lime water, then you plus CO2 gives you calcium carbonate. Okay, so white precipitate, then plus water. Okay, yeah, so this is the white PPT, in case you're wondering what it is. Alright, so reactions that produce this acid carbonate, or even combustion of alkenes and alkenes in organic chemistry. Okay, yeah. Okay, likewise you will see effervescence, because it's also a very insoluble gas, insoluble in water. Okay, all this nothing new. Okay, and then also you have ammonia gas. Okay, which is a colorless and pungent gas. Okay, this one no effervescence. You test with a piece of moist red litmus. Okay, so the red litmus will turn blue. Okay, must write the word moist. Okay, type of reactions that produce this is a ammonium salt and alkaline reaction. This one gives you ammonia plus salt plus water. Okay, this one also you learned before lah. Okay, the reaction actually is like, for example, ammonium chloride plus sodium hydroxide. This is like the test for cation, right? For ammonium ion, then you get sodium chloride plus ammonia gas plus water. Okay, alright. Okay, then okay, for your chlorine gas is greenish yellow with a pungent, like swimming pool kind of smell lah. Okay, you use a moist blue litmus. Okay, so the moist blue litmus will turn red and then get bleach. Okay, suddenly I change to orange. Okay, and then for sulfur dioxide is colorless. Okay, colorless and then pungent. Normally we don't let you do this in practical lah. Okay, because it's an acidic gas. Right. Okay, this one is like a acidic gas. Chlorine also lah. So normally we don't. So how you test? Okay, you have a filter paper soaked with acidified potassium manganate. This one you will get. You will use it lah. Okay, in some practical potassium manganate. Okay, it's for redox kind of QA. So basically turns the purple acidified potassium manganate turns colorless. Okay. What happens is this, basically it turns the SO2 to SO4, 2 minus. Then the potassium manganate, the formula is KMnO4. This is your, this thing, acidified potassium manganate is KMnO4. Yeah, okay, so itself, this thing is purple color, then become Mn2 plus. Okay, we will study more about this in the next chapter. Okay, under redox, it's a redox reaction. Okay, redox. Okay, we'll do this next chapter. Okay, for now, just know the observations. When you test sulfur dioxide, it basically the purple potassium manganate turns colors. Okay. Alright. Okay. Then this is it for this QA. Okay. Pretty short chapter actually.